Okay, so 3 thinking maths moments from this week. And these are moments that sort of got me thinking and wondering about what's happening in this moment. Okay, so number 1 moment, I asked the students to tell me 8 things they knew about 8, or 8 facts about the number 8. So a lot of the kids came up with things like 1 plus 7 is 8, 2 plus 6 equals 8, 3 plus 5 equals 8, 4 and 4, the double to get to 8. So that would have been most of the students. Then there was another group of students who I was really interested in. So they were doing things like bigger numbers, higher numbers. So they do, 100 minus 92 equals 8. Or they'd be playing around with division. So they'd have things like, 72 divided by 9 equals 8. Or then they'd step it up in terms of, saying, oh, what about 220 minus 212 equals 8? So what was interesting to me was their repertoire, the amount of things that they could do with 8, how they could play with 8, how they could come up with all these different facts about 8. I was thinking what an advantage that is to have that repertoire, that flexibility with number, and thinking about how do we encourage more of students working towards this. Now these are obviously really, really important foundations, really, really important. But how do we then get students to move beyond that and to take more risks and to try out working with bigger numbers, to try different operations, even if they don't get it straight away? My number 2 moment relates to rainbow facts, so partners to 10, and the knowledge that how crucial these rainbow facts are. So we were playing I Have You Need with the rainbow facts and then extending it to partners to 20. So we started with, my target number being 10. And then I said, I have 4. How many more do I need? And the students would then say, you need. Now, a lot of the students knew their rainbow facts and had that automatic. And so they could say, okay, well, you need 6 more to get to 10. But what was really noticeable is that there were a number of students who didn't know their rainbow facts. And so this is what they were doing. So we'd already been using our hands and we said, okay, so we've got our 4. How many more do we need to get to 10? So what I saw then was a number of students going 1, 2, 3, 4, 5, 6 to get the 6. And that happened across a number of classes. So I guess my key thing there is how many of our students know their rainbow facts? How many don't? What an incredible advantage it is to know your rainbow facts, because we can apply them to the 20s and then adding 2-digit numbers. So for example, if I know 4 plus 6 equals 10, then I also know by extension that 14 plus 6 equals 20. And so with the students then we're going, okay, can you see the rainbow facts there? There we go, it's the 6 and the 4. That's our rainbow fact, our 10. And then we've got another 10 there, here. And I guess it's really crucial to ask the student, what's the value of this one? How much is it worth? That's 10, or 110. If I know 2 plus 8 equals 10, then I know that 2 plus 18 equals 20. Again, we can capture the 10s, the rainbow facts to 10, 8 and 2. And then we've got this other 1. What's the value of that 1? Okay, that's a 10. 1 times 10 equals 10. So if you know your rainbow facts to 10, then we can extend them to 20. Then when you're adding 2-digit numbers, you can look for the ones that add to 10. That can help you. So it's an incredible advantage. So just check with your students how many of them do know their rainbow facts to 10, and then see if you can extend them beyond that to use their rainbow facts to 20s and beyond. Moment number 3 happened in year 6s when we were working on a problem string. So the setup was that we had packets of gum and there were so many sticks in each gum. In this case, one packet had 12 sticks of gum. And so we started off with that and I said, okay, so we had one packet, has 12 sticks of gum. How many sticks of gum would we have in 2 packets? And so that was pretty easy for students. They could say, oh, well, it's double. It's a double there. How do you know? Okay, well, 1's 12, so 2 would be 24 because 2 12s are 24. Then we moved on to 4. So if we have 4 packets, how many sticks of gum? And again, they were pretty quick to work out, okay, well, if you double 2 packets, that'll give you a 4, so you need to double 24, and that will give you 48. So double 24 is 2 times 24, and that was 48. Then we continued on with the 8, same thing, they worked out the doubles. Then on to 10, and then the issue there was around the add a 0 situation. Okay, and this is something we need to address because that's a problematic rule, especially when we come to decimals. Okay, then we moved on to 9 times, and so they were able to work out, again, by emphasising the fact that we need to use what's in the problem string. So they said, okay, well, we know that 10 times 12 is 120, so we could do 10 times 12, so that's 120, and then we could just take away one lot of 12. And that's 12 minus 12, and so that gives us 108. Now here's the significant part. When we got to 25 times 12, 25 packets, how many sticks of gum? This is the part that really challenged them. There were more than 6 different answers for this one. And that included students working with algorithms. So I got them to go back and rechecked, and eventually we got to 300 was the common answer. And so I asked them, can someone tell us how we can use what's already in the problem string, something we've already worked out, to help us get to 25 times 12? And there was quiet, absolute quiet. Eventually a braver person or a couple of people had a go. And they had it. So they said, okay, well, you can use the tens. Okay, so if we double the 10, that gives us 20. So we double the 120, that gets us to 240. Okay, so that's our 20 packets. Then we've got to find the 5. And so they said, okay, well, then we can add 4 packets, and that gives us our 48. And then we can add another 1, and that gives us 12, and that altogether gives us 300 sticks of gum. Okay, so that was good. Okay, so they'd use what was in the problem string to help them work it out. But it took quite a bit of work to get there. Interestingly, no one used the 5 is half of 10 strategy. So if we go back to what we already know, we know that the 20 packets is 240 sticks of gum. And so we just need 5 more. So if we've got our 10 is 120, then 5 packets is half of 120. So there's our 5 packets is half of 120, which is 60, which gives us our 300. So hopefully now, over the coming weeks, they'll start to play with these numbers a bit more